Let's take a look at those treatment facilities that make Fairfax Water such a renowned utility.
I'm standing in front of the Potomac River, which feeds our Corvallis Water Treatment Plant, which is actually located 5 miles and 180 feet elevation from here. That plant is rated at 225 million gallons per day. In order to get the water from here to there at that rate, we have 6 very large pumps. 4 of them are 60 MGD, million gallons per day, powered by 3,000 horsepower motors. The other 2 are 1,500 horsepower motors that deliver 30 million gallons per day each. The unique thing about this source is we have 2 intakes, one onshore to my right, one 750 feet behind me submerged beneath the surface. The conditions of the river dictate which source we use. Sometimes the quality is better offshore, sometimes it's better onshore. The operators can select which source they use remotely from the plant. By being able to select between these 2 sources, we can dramatically reduce our treatment costs. The Griffith Water Treatment Plant, rated at 120 million gallons per day, is fed from an 8 billion gallon reservoir and a 60-foot dam. To get it from there to the plant, we feed it through a 72-inch pipe and a raw water pumping station with 7 pumps. The largest one being 1,750 horsepower, the smallest one being 750 horsepower.
Meet Doug Grimes, our production manager. He is going to take us on a tour of the facility and describe the treatment process.
We saw the raw water pump station earlier today, and we've pumped that raw water up to the treatment plant. That's where we begin the actual treatment of our water, and that first step is coagulation. To coagulate the water, we add a positively charged chemical, in our case, polyaluminum chloride, to mix with the negatively charged particles that we want to remove. As that mixes, it causes the particles to come together and form what we call a flock. That water in the flocculation zone is gently mixed, and as those particles bump into each other, they form a bigger and bigger flock, which then in the next step, sedimentation, is allowed to settle to the bottom of the tank where it can be gently removed for the water to head to the next step of the process. After sedimentation, the next step is ozonation. Ozone is a very powerful disinfectant that also provides taste and odor benefits, but we have to generate it here on site. And the way we do that is we purchase liquid oxygen. It comes in tanker trucks. We take that liquid oxygen, travel it through vaporizers, which converts it to a gas. Then the gas travels to our ozone generator. Inside the ozone generator, a neat thing happens. We take electricity, combine it with the oxygen gas, which converts some of that oxygen to ozone. The ozone then travels to the ozone contactor, where it travels through fine bubble diffusers, which produces little tiny bubbles which travel up through the water, mix with the water, break up the organic compounds that we want to remove so they can be filtered out during the next step, which is filtration. The filters at Fairfax Water are multimedia filters, which have 2 layers. The first layer, granular activated carbon, or otherwise known as GAC, and the second layer, sand. Those 2 layers together filter remaining particles and prepare the water for the next step, which is disinfection, where we take a small amount of chlorine, add it to our already filtered water, which kills bacteria and protects the water as it travels through our distribution system out to our customers. As you can see, we've got quite a large plant with a lot of equipment to keep track of. And our 3 operators that we have on shift to make routine rounds could use a little bit of help. That help is the SCADA system that you see behind me. The SCADA system not only monitors most of the processes around our plant, but enables us to start and stop pumps, open and close valves, and adjust chemical dosages based on the needs of the process. It also is an extra set of eyes, keeping track of potential alarms and letting us know if any treatment processes start to get out of bounds. When we get that signal here, the operator can go out to the plant and make the necessary adjustments on the spot.